Alright, here we go. Chapter 2, Section 4. There are 4 objectives in this lesson, and we're going to tackle the first one now. We're going to use long division to divide polynomials. So here's a list of the steps that we will go through to do this. I'm not going to read through them, but feel free to pause and read this if you'd like. On the example on the next slide, we will go through and do each one of these steps as we explain the example and how to move along through the example. So feel free to jump back to this point in the video at any point. Here's the example. We're going to divide x squared minus 2x plus 6 by the polynomial x plus 2. So it looks like this: x squared minus 2x plus 6 divided by x plus 2. Now, what I ask myself initially is, or I focus in on the x here, so I ignore the plus 2 and I focus just on the x, and then I ignore the minus 2x plus 6 and I focus in on only the x squared. So basically I'm only looking at the first term here, the x, and the first term here, the x squared. And I ask myself the question, what do I multiply x by to get x squared? That answer is x. And so I would write x up here. Now you'll notice in this example that the x is not written over the x squared, it's written over the x. Some people like to write it on the x over the x squared. That's totally fine. Other people like myself like to write it over the x term here. I like to line up my terms. So my x term would be over my x term, my constant would be over my constant. If I'm left with anything at the end, I know it's a remainder because it's not over anything. So again, what do I multiply by x to get x squared? I multiply it by x. At this point, we now need to take this value x and multiply it by x plus 2. So we're going to distribute the x and multiply it by x plus 2. Well, x times x is x squared, and x times 2 is 2x. Now, in any long division process that we've gone through since, I don't know, 3rd grade, at this point you've probably never done it with polynomials, of course, since 3rd grade, but we always subtract at this point. So there's no little subtraction symbol out here, but that's what we're doing. X squared minus x squared is nothing. It's 0, so we don't write anything down. Here we have negative 2x minus positive 2x. So if you take negative 2x and you subtract positive 2x, you get negative 4x. We drop down the 6 at that point. So again, like in any long division problem that you've been doing since 3rd grade-ish, once you do that subtraction, you do drop down the next term. And so we drop down the positive 6. At this point, we start the process all over again, and we only focus on the first terms. So we have x plus 2 here, but we're only going to focus on the x. Down here we have negative 4x plus 6, but again, we're only going to focus on the negative 4x. And we ask ourselves that question again. What do I multiply by x to get negative 4x? Well, I multiply x by negative 4. So now we go up here and we write negative 4 over the constant term. And we then have to multiply negative 4 by x plus 2. So negative 4 times x plus 2 is negative 4x minus 8. Now you can see in this example that there are plus symbols here, and that's because, here, let me show you. So here, when there was subtraction, we just did x squared minus x squared and negative 2x minus positive 2x. But you always have the option of instead, let's see if I can erase that. You always have the option of instead changing these to the opposite of what they are and adding them. So down here, instead of having negative 4x minus 8, in this example they changed the negative into a positive 4x, and they changed the negative 8 into a positive 8, and they chose to add them together. So if you change the answer that you got to the opposite, you are able to add them. So you get negative 4x plus 4x is 0, and 6 plus 8 is 14. At that point, we realize that 14 is a remainder. So our answer is x minus 4 with a remainder of 14. And the way we write remainders, you can see down here, x minus 4. The remainder is written as plus 14 divided by x plus 2. It's right there, divided by x plus 2. So that is how we do polynomial long division. So again, feel free to jump back to the point in the video where it explains the steps. You can follow along with them and pause it, or you can listen to my example here if you'd like as well. All right, let's jump on to the next objective. Let's see, why is it not going there? I know why. Here we go. So now we are going to use synthetic division to divide polynomials. So you can see here it says, we can use synthetic division to divide polynomials if the divisor is in the form x minus c. So down here in this example, the divisor is in the form of x minus c. It also could be x plus c, as long as if that first term is linear. As long as if it's raised to the first power, you are able to do synthetic division. This method provides a quotient more quickly than long division, and we're going to compare the two methods right here. So if we're dividing this long polynomial, x cubed plus 4x squared minus 5x plus 5, if we're dividing that by x minus 3, you can do long division this entire way here to get your answer, or you can do what we're going to do over here, synthetic division, and find the answer more quickly. And sometimes students, when they see synthetic division for the first time, they'll say, why would we ever use long division when synthetic division is much quicker? I would say anytime you do have a divisor that is in this form, x minus c, it is always best to do synthetic division. It is quicker and most people find it easier. However, there are plenty of times where you have to divide by, your divisor is in a form that is different than this. It's not a linear factor, in which case you cannot use synthetic division. So you do want to make sure that you do know how to use long division, but in this case we're going to do synthetic division. So we are dividing by x minus 3, and you'll notice that in this little half square box we put the number 3. You always put the opposite. So since this says negative 3, x minus 3, we're putting positive 3 over here. This is the factor, this is the 0, or the solution, or the answer. So x minus 3 is the factor, 3 is the 0, potentially. And so it's essentially the opposite. The numbers that go across the top here, 1, 4, negative 5, 5, you'll notice those are the coefficients of these terms here, 1x cubed, 4x squared, negative 5x, and 5. Those values are written here without the variables. And then we would draw this line in. And you leave the 3, 21, 48 all out. That's not there. So initially, let me put this in. I'll try to write it neatly. Your problem probably first looks like this. 1, 4, negative 5, and 5. With a line. You don't have any of those other numbers in there. And so the first thing you do is you drop down the first number. It goes underneath the line, as you can see I just drew right there. And again, this is a little messy, I apologize for that, but that's where that 1 comes from. This 3 that is written here comes from multiplying the 3 in the box by 1. So you're always taking the number that's down here and multiplying it by this one up here. That answer goes here. Then it's adding. So 4 plus 3 is 7. So now you would be trying to figure out what number goes here, and it comes from taking this 7 and multiplying it by that 3. That number goes there. Again, we add. So it's just a series of multiplying and adding. When we add those, we get 16. Now you take the 16 and you multiply by 3. You get 48. When you add the 5 and the 48, you get 53. And so the last number when you're doing synthetic division is always the remainder. So you can see the long division done over here. The 53 is the remainder, the 53 is the remainder. And then to work backwards so that our answer actually looks like this up here, x squared plus 7x plus 16 with a remainder of 53, I work backwards. Again, 53 is the remainder. So I know 16 is the constant term. That's the term that's written without an x. I know the 7 is the linear term, so that's the number that's going to be written with x to the first power. And I know this is the quadratic term, and so that will be the number that's written with the x squared. And so technically I would like to see the answer to this written in this way. It is 1x squared. That's a squared. That's a terrible 2, but that's what it is. Plus 7x plus 16. And then it's plus the remainder, which is 53 over x minus 3. That's a little messy again, sorry about that, but that's how you use synthetic division. So it does the exact same thing as long division, but a lot of people find it much easier. And in long division, you have to divide and subtract, whereas in synthetic division, since you change the -3 to a +3, you're able to multiply and add. And most people prefer to multiply and add than to subtract and divide. Okay, let's move on. That's objective 2. Objective 3. Evaluate a polynomial using the remainder theorem. So here we are given this polynomial here, and you're asked to use the remainder theorem to find f of 2. So in some of the work that we did back in, I believe, the Chapter 1 review that we did at the start of the year, if I asked you to find f of 2, what would you do? Well, you would take the 2, and you'd replace all of the x's over here with the number 2. And so that work is down here. F of 2 equals, we replaced the x up here, the x cubed, it's now 2 cubed. Instead of -4x squared, it's -4 times 2 squared. We're just replacing each x with the number 2. That answer, when simplified, is 5. This entire objective is showing you that if you chose to use synthetic division instead, you could take this 2, f of 2, you'd put that right into that half square box. You would set up synthetic division using the coefficients and the constant term there. Here it is. And once you complete the synthetic division, boom, your remainder is the answer that you would get from plugging in 2 to the polynomial. So if you plug in 2 to the polynomial, you get an answer of 5. Or if you did synthetic division and you plugged in the number 2 into this half box, your remainder is the answer that you get down here. That will always be the case. So that's how you use the remainder theorem to evaluate a polynomial. And our last objective is to use the factor theorem to solve a polynomial equation. So if you were asked to solve this, you want to find out what values of x you could plug in to get 0 for an answer. It's a little bit timely, but the good news is when you're using the factor theorem to help you with this, they give you one of the solutions. It says, given that 3 is a 0, when it says it's a 0, that means it's a solution, it's an answer. And so immediately we can jump to synthetic division. If we know that 3 is an x-intercept or a solution or a 0 or an answer, those all mean the same thing. We take 3, we put it in our little half square box over here. We set up our synthetic division using our coefficients and our constant term. When you complete the synthetic division, you always should have a remainder of 0. Because if 3 is considered a 0, when you complete the synthetic division, you would get 0 as an answer over here. If you didn't, that would mean something went wrong in the process. And so, to the right here, it shows what you would get if you did long division, and you'll see again that they had to use x minus 3 because it's always the opposite that you would have here. And so the answer looks like this up here, 2x squared plus 3x minus 2. So clearly if you take x minus 3 and multiply it by this answer that we got up here, 2x squared plus 3x minus 2, you would get the original polynomial right here. So equivalently, as they write, the entire polynomial could be written in factored form as x minus 3 times 2x squared plus 3x minus 2. Now it says to solve this polynomial equation. So now we'll take it down here. If the original polynomial could be rewritten in factored form, here it is, the original polynomial. Here it is in factored form. We're going to continue factoring if we can. We'll drop this factor down. This right here is a quadratic trinomial with a leading term of 2. If you factor 2x squared plus 3x minus 2 using whatever method you choose, you will factor it down into these two factors, 2x minus 1 and x plus 2. So now we have 3 factors that are being multiplied together to give you 0 for an answer. If you multiply 3 things together to give you 0 for an answer, one of those 3 things has to be equal to 0. Either x minus 3 is 0, or 2x minus 1 is 0, or x plus 2 equals 0. Once you solve each of those 3 things, you'll have answered your problem. You have now solved it. So if we went back to the original polynomial up here and we plugged in the number 3, we know that, yes, we would get an answer of 0. If we plugged in the number 1/2 for each of the x's up here, we would get an answer of 0. And if we plugged in the number -2 up here for the x's, we would get an answer of 0. Those are our 4 objectives. This was a little bit lengthy today, this video. But again, feel free to rewind if needed. Use this video, whatever way you choose to help you be successful. Let me know if you need any help.